This problem, we want to calculate the bromine concentration for a mixture of hydrogen bromine and hydrogen bromide. And what we're going to do is we're going to start off with a Rice diagram. So we're going to have the reaction we're going to write, then we're going to write down the initial concentrations, the change, and then we're going to write down the equilibrium concentrations. We're going to input the equilibrium concentrations into the equilibrium constant and solve for the extent of reaction. Okay, so what is our reaction? Our reaction is H2, and everything's in the gas phase, so I'm going to ignore the phases up here. But remember, in the equilibrium constant expression, you don't include solids or liquids, pure liquids. And now I have 2 HBr, okay? And what are we given? We're given the initial concentrations, 0.6 molar of this, 0.6 molar of this, and 1.25 molar of this, and we need to know K. And K is equal to the products to their stoichiometric coefficients, so that's HBr squared over H2 Br2. And this is the reaction quotient expression, and at equilibria, this is equal to 50. Okay? Now, what we want to do now is this is the initial conditions, and if the question was, do we make products, HBr, or do we make reactants, we would stick these values into this and ask ourselves, is it less than, equal to, or greater than 50? If it equals 50, nothing happens. If it's greater than 50, it goes in this direction, making reactants, and if it's less than 50, it goes in this direction, making products. But we're not after where it goes. We want to know how much bromine we have at the end of the equilibrium. And we don't know which direction it goes. But we're going to say that it goes in this way, so we're going to go a minus x here, and a minus x here, and a plus 2x, okay? So this is saying every time one of these is consumed, one of these is consumed, and 2 of these are made. And the magnitude of x tells us how far we are from equilibrium. So once we reach equilibria, we have 0.6 minus x of this. We have 0.6 minus x of this. And we have 1.25 plus 2x of this. Now what we're going to do is we're going to put these conditions into the equilibrium constant expression and solve for x. Once we know x, then we'll go back to here and we'll say 0.6 minus x to calculate the bromine concentration. So K is equal to 1.25 plus 2x all squared divided by 0.6 minus x times 0.6 minus x. Now let's take a second out here, okay? There are two different entities on the left-hand side, an H2 and a Br2, and there are 2 entities on the right-hand side. They're both HBr. And so this is going to be a quadratic expression. The highest power is 2. If these are mixed in stoichiometric proportions, we don't have to solve the quadratic equation. We can complete the square, okay? The general idea of this is that I want to say K is equal to some power to the 2. And whatever this expression is, and then I take the square root of both sides, and I get rid of this square term. Incidentally, if there had been 3 species here and 3 species here, and they were mixed in stoichiometric proportions, I could have completed the cube, okay? So what I want to do is bring this into a format that's like this. So I can now say that K is equal to 1.25 plus 2x all over 0.6 minus x. I'm going to do this in 2 steps. Squared, squared. And this is equal to 1.25 plus 2x all over 0.6 minus x all squared. And this is equal to K, okay? Now I can take the square root of both sides. And remember, square root is to the power of 1/2, but I'm going to write it like this here. And now we get rid of the square term. And I can now, I want to solve for x. So I have 1.25 plus 2x is equal to 0.6 times the square root of k, which is 0.6 minus x times the square root of k, which is 0.6 times the square root of k, and I'm multiplying this over here, minus x the square root of k. Now I want to bring everything with an x to one side, so I have 2x, I bring this over to here, plus x times the square root of k is equal to 0.6 the square root of k. And now I'm going to bring over the 1.25, so it's minus a 1.25. Now I'm going to factor out the x. So I have this as x equals some term. So this is so x is equal to 2 plus the square root of k. And this is all equal to 0.6 the square root of k minus 1.25. Now I can solve for x. So x is equal to 0.6 the square root of k minus 1.25 all over 2 plus the square root of k, which is equal to 0.6 times the square root of 50 minus 1.25 all over 2 plus the square root of 50, which is equal, and now I get out my calculator, and I get 0.33. Okay? Now that I have 0.33, I can substitute this back into here, and I can say that the bromine concentration at equilibrium is equal to the initial 0.6 minus a 0.33, which is equal to 0.27 molar. Okay? Hopefully that makes sense and helps you out.